Okay, and again, we're focusing on SolidWorks Premium because, and I'm a technical guy, but this is an incredible deal, and so we want to make sure everyone's as informed as you can be on what is in SolidWorks Premium, so that if it's a fit for you, you can take advantage of some really good pricing right now. You can save a lot, as you can see on the screen. You only pay the price of SolidWorks Standard, which in itself is a great CAD program, but you get everything in SolidWorks Professional and Premium for the price of SolidWorks Standard. So you can see the list there that besides just SolidWorks CAD software with all its features, you get all these extra things too that help you get your job done faster, automate a lot of tedious tasks, allow you to do very specific tasks in your industries with a lot less work, and a big savings there. So that's why we're focusing on SolidWorks Premium this week. All right, as you can see, SolidWorks doesn't bill itself as being the best tool for one specific industry. They're a very good fit in a wide range of industries. That's why we had to do 3 sessions this month, and we could do more, again, but with the grouping and just picking the larger industries, we were able to fill a month anyway. But again, we're going to kind of focus in. You can see there's a really good presence in industrial equipment because, again, for mechanical machine design, it's hard to beat. Again, packaged goods would fall in there, energy, oil and gas, those kind of things. They're all in there and well represented by SolidWorks. And so let's take a closer look to see kind of what are the things people in these industries are looking at, some of the challenges they have to meet, some of the trends. And again, you know, we're lumping several industries that have similar challenges together. And so again, it's industrial equipment, energy, plant and process, but it can also include heavy machinery, you know, manufacturing and automation, oil and gas, you know, those kind of things. Very large systems, very mechanical systems. Aesthetics is less of a factor here than it would be maybe an automotive or consumer product. It just really needs to function. It needs to be predictable and safe. We need to get them to market very soon, again, because it could be a discovery of a resource or automating a manufacturing opportunity. We need to be able to present a you know, a functioning proposal, and we need to be first so that we can get that bid. And in the terms of energy, we need to be on site and running and getting a return on the investment of this very large capital project as soon as possible. More and more electronics and mechatronics are being integrated in. So again, some of the more specific challenges shared with all these. We need to, on the quality side, again, we need to have a paper trail for our design process, so we know we're always working on the correct versions. We have a good history of the development as we've taken this product from just an idea all the way through manufacturing. So there's a great data management product in SolidWorks Professional, which you would receive if you buy SolidWorks Premium, again with this promotion this month. Governmental regulations and compliance, you know, it could be environmental things, safety, and again, having a paper trail without having to do it manually. So again, you can always show what was done at any point throughout the design cycle. There's performance goals that we have to hit. We need to know that before we make one of these machines that we are going to hit those. We're going to get predictable performance. Okay, if we put things out in the field that are going to break, that's going to cost us a lot of money. Okay, in terms of reducing costs, you know, we need to always improve our margins. We need to eliminate rework and mistakes that we find after we've already built a prototype, or even worse, once we've started building these things. To find a problem can be devastating, so we need to have the tools up front so we can check all these things and know that when we do build this, it will work. Optimizing designs to meet the needs of manufacturing. It has to do with tolerance and controlling our tolerances and tolerancing our models effectively so that we're not spending too much money by tightening everything up too much. But obviously it can't be too loose either for things to actually work in the field. So that'll, the tolerance analysis tool in SolidWorks allows us to get a feel for which dimensions and tolerances are affecting target goals in the assembly. Gives us some insight into that so that we can make changes to tolerances effectively. Okay, reducing time to market. That's all about just going as fast as possible and beating competitors to the market. As I said, if you're bidding against other people for an automation job or something like that, we need to have a good-looking concept in front of the client as soon as possible, because that gives us an edge. We need to be able to communicate the design well. eDrawings Professional helps with that. Not only we get a 3D model you can spin around, but we can also measure it and mark it up. Reusing existing data is huge, and I'm going to lump that in with excessive time spent on repetitive or mundane tasks. Again, some of these things we just do over and over again in new designs. So once something is engineered and perfected, I don't want to have to keep redrawing that or keep redoing that every time we get a new bid and we have a slightly different project. So there's ways in here we'll show you how to how that's automated and how that can we can save some of that those tedious tasks and let SolidWorks take care of those for us. And then reducing and eliminating prototypes. That is nothing but money and time right there. We may not be able to eliminate all of them, but we want to reduce that number because, again, it just slows us down getting to market, and it costs a lot of money to make these functional prototypes. All right, so let's jump into the first one here. Again, today's going to be a little bit some slides, me talking, some live software, looking at some customer success stories and some videos just to kind of tell the story here. So let's jump into SolidWorks now, where the fun stuff is. All right, and so again, this is concerning these industry-specific tasks that we need to repeat over and over again, as well as, these tedious things that we need to keep repeating, and how SolidWorks can automate a lot of that. All right, so this is a process skid for oil and gas, and with a lot of these types of products, we're going to have routed systems. We're going to be moving fluids from one place to another. It could be rigid piping, it could be flexible hose, it could be wire or cable harnessing, but all of these things, permeate these products, and we want to build those into our 3D model because it gives us an accurate bill of materials. It helps us see if there's going to be any problems with fit or finish, rather than finding that out too late down the road. So we want to model that in while we're designing this thing. Most people, if you're not using SolidWorks, you kind of have to wait till the end, and then you may find problems which are going to set you back. So let's jump right in here and make a pipe spool just so you can see how little work it takes to get something very complex. All right, and this first thing I just did there was using a display state. Again, we're talking about very large, complex systems in this industry, and so we want a lot of tools to be able to manage our assembly, whether it be for performance, very, very large assemblies. SolidWorks has excellent performance management tools for large assemblies, as well as visualization tools like this display states, where even though the whole assembly is open, I'm not working on the entire assembly at all times, so I want to kind of be able to focus and visualize in the area of my responsibility. So display states is a great way to do that, and it allows me to kind of hone in on what I'm working on here. All right, so let's look over in our library here. So with SolidWorks routing, again, this is for doing routed systems, rigid pipe, flexible hose, wires, cables, ducting, cable trays, any of those kind of things that go from point A to point B and branch off and either organize things or move fluids. Again, they all behave similar ways, different cross sections, but I want to be able to do it quickly, but I need an actual accurate version of it in my 3D model, so that, as I said, for purchasing and bidding, my bill of materials is correct. All right, so we're going to start off here, and what I need to do is do a pipe spool that goes from this blue pump down here and connects into this vessel up here, made out of rigid piping. Okay, so I'm going to go into my routing library, which has a lot of things in here, and we can also, I just want to show, we can, with 3D Content Central, a lot of this, in these industries, we're going to be using a lot of vendor parts. Our expertise is how to integrate things and how to innovate and get a solution at the end using these off-the-shelf components and our own knowledge. Okay, so lots of vendor parts, motors, actuators, valves, motion control, rails, electrical connectors, lots of things like that that we're going to be using off the shelf, and we can get 3D models right here directly from the vendor itself at 3D Content Central. It's free here, and it saves us the time from modeling this part. We can go in and configure it, and we'll get an accurate 3D model. They're certified models that we can then throw into our assembly and not spend any time on that, again, because it's just off the shelf. We're not making any changes to these things, but we want to integrate them into our designs. So that's one way. The more generic type things like fasteners, gears, bearings, bushings, those are also in the toolbox library, which is part of SolidWorks Professional, which you would get with Premium, and that saves us a lot of time from having to draw any of these things in the first place, as well as size them correctly, and I'll show you a good use of that too. But again, those are the tedious things that we do over and over that need to be automated. So let's start here with these fittings. We're going to start with some flanges. All right, I have a welding neck flange here. I'm just going to pull it out into my assembly, and you can see it there. And then as I drop it down to the pump, you notice it orients itself correctly and mates to that pump, just as I would if I was assembling this. Okay, it's chosen the correct size here at 4-inch. All right, and now routing is going to kick in, and now we're going to set all the properties. Okay, so we got 4-inch pipe at schedule 40, so we know this whole route is going to be done with that. And I can tell it to use elbows. Anytime we take a turn, I can either bend the pipe or I can insert an elbow, and we're going to go with that on this. But again, it's just checking boxes, telling it what we want, and we let it go. Okay, so there's the start of this pipe route, and you can see it's driven by a 3-dimensional sketch line. Okay, at this point, there's no wall thickness or anything. Again, we're just going from point A to point B, and then we'll get the detail here in a second. But now I can just drag that line up. Okay, and the pipe follows it. And so now I'm in a 3D sketch, so I'm using 3D sketch lines. Let's close that. There we go. All right, and so now I'm just going to attach to that and bring it across. I need it to come across this enclosure here. And you'll see as soon as I finish that line, it puts that 6-inch radius on center at the turn, and it's going to put an elbow there when I'm done. All right, and so now I need to go kind of backwards along Z to meet up with this other fitting up there. Okay, and there's the other line. So you can see what it's done so far with about 3 clicks. All I'm doing is drawing some lines in 3D space, and it's taking care of the rest for me. And I can keep adjusting it until I lock it down. Okay, so where's this route going? Okay, it's coming from the pump and it's going into the vessel up here. Okay, so now I just bring in another one, flange that is. All right, so we've got the 4-inch flange on there, and here's the rest of the root coming out, and I can just join those together now and watch what happens at the intersection. Okay, right there, they're joined, and then it's going to put the bend in there for me. All right, now that I think about it, we can save a pipe section there, and we can just go directly from the elbow and weld direct to the flange. So just a quick right click, and you can see we've got some very specific commands for the piping route here, and I just want to remove that pipe. Okay, and you can see now the elbow goes right in and welds direct. Okay, looks good. Let's finish it and let's see what we get. All right, so just like that, dropping a flange, drawing a few lines, putting another flange at the end. That's about all I did. A couple clicks, dragging and dropping a few parts. And from that, I've gotten this whole thing where I've got individual pipes, elbows, flanges. I've got a full assembly of this pipe spool so far. Again, without hardly doing anything. To do this part by part by part, one by one, it's possible, but it would take a long time. And again, we have real limits on our time to market here. All right, so let's go back in and make some changes. Now we want to add some more things, maybe some branches to this route. Okay, so we have another, we want to branch into this connector here too. So let's bring in another flange. All right, and that one is a 3-inch. Okay. And we're stubbed out there. And we want to connect it into this main line down here. So all I need to do, again, with the right click, is I just need to put a split in the root somewhere where I'd want this pipe to connect. Okay, and I could put a dimension on there to make it very specific. And now using auto route, I'll have SolidWorks finish that for me, make a connection from this first pipe into this main one here. Okay, and it's as easy as just picking one point to the other. Okay, now it's warning me here because again, SolidWorks is intelligent. It's keeping track of all these properties of all these pipes. If you remember, this is a 3-inch coming out of here, but our main root here is a 4-inch, and it's just alerting me to that will need to be handled some way. All right, so that's what it came up with first. Yep, that works. Not exactly what I'm looking for, so now I can just kind of go through some different solutions. There's one. That looks, yeah, let's go with this one. Okay. There we go. So again, 2 clicks and I got this very complex root here. And since I haven't dimensioned it all yet, I can still move it up or down. I'll take this and move it back a little bit. And now again, rather than eyeball it, I can see it a little bit tight in there. I want to really make sure everything's clearing. So let's drive it with a dimension. So I'll pick this line, which is the center line of that pipe and the back face of that enclosure, and I can put a hard dimension there that's going to hold that pipe there. Let's just say we need 5 inches. Okay, now I can change that anytime. All right, everything fits. Looks good. Again, here's SolidWorks watching out for me, telling me I do have an issue where this 3-inch pipe comes into the 4-inch. Okay, no problem. We've got all these standard types of fittings, so we'll just get a reducing T. And again, I'll just drag this out into my assembly, and as soon as I put it on that junction, you'll see it orients itself and then correctly chooses the 4x4x3, schedule 40. There we go. Okay, so again, just as easy as that. If I want to put in another component here, another inline component, we'll just split the root again. Okay, so that's now a point that I can connect to, and let's go into some equipment here, like maybe a valve. All right, we'll drag this out, and this is just a SolidWorks assembly, but it's routing aware, and so now when I drop it on that junction, it's going to orient itself and place it in there. All right, looks pretty good. Again, just some dragging, dropping, and some simple 3D line sketches. I'm getting a lot of work done here. All right, so let's open that so we can really see what we've gotten so far. All right, so here's this pipe spool I just created in the context of that assembly, which is good. So I know if the vessel ever moves, these pipe roots will go with it, and all that will update because we're in parametrics, and that's what it does for us. We could do a little bit more work here, but again, it's just interesting to show. I basically dropped a few flanges, dragged and dropped a few flanges from my library, drew a few lines, put a couple splits in, dragged a couple of other components on there, and what I've gotten by doing all of that is all these individual components. There's the elbows, you can see. Okay, the other assemblies, the other assembly pieces in there. Here's the T. Again, separate components, so I'm going to get an accurate bill of materials as well as all the individual pipe pieces. And you can see whenever I split and put this T in here, it trimmed up those two pieces of separate pipe now. Okay, so everything is accurate as well as being really fast. And again, at the bottom, the whole thing is just driven by this three-dimensional sketch on center line. It's very easy. You can see a lot is happening in the background that I don't have to worry about, which is the way I'd like to keep it. All right, let's put a few other pieces on here. All right, like I need to put a pressure gauge here, and so we're going to mount it with a threadlet. Let's drag that out. Okay, and we'll do a 3x1. Okay, so it goes on the outside of a 3-inch pipe, which is correct, and it's got a 1-inch inlet. There we go, and again, for production, I would route this thing correctly, or sorry, I would line it up, make sure it's vertical. That looks pretty good for now. All right. Okay, so this is interesting. Again, talk about these tedious tasks that we constantly have to reproduce. Obviously, to anyone watching, this threadlet is not helpful unless there's a hole in that pipe, right? Okay, so oops, I forgot to create the hole first. It doesn't matter. You can just drop the part on there, and because this threadlet is a smart component, it comes with the required features, and I can just click this button to tell it, yes, I want to apply those features. And you can see up here, this is what I'm going to get, this hole. Yes, that's what I want, and I want to apply it to this new tube down here. So I just need to tell it this is the new pipe. I get a green check, and that is really it. Just like that. So if I hide this part now, you can see it cut that hole for me. If I ever move the threadlet along that pipe, the hole will move with it. Just less for me to worry about. Let the software take care of some of these things. All right, now that we have the threadlet, I can put the piece of equipment on there I wanted to, which is a pressure gauge. Okay, again, just dragging and dropping. This is how it should be. All right, looks good. So again, a lot of actual geometry and accurate bill of materials information from very little work. So let's go and create a drawing to see how we're going to build this thing. Okay, so we've got a C-size drawing all set up. And I'll just do a front view. Okay, and a top. Maybe we'll do an ISO too. Yeah, that looks good. Put that down here. All right. I need a little bit, I don't like my scale that much. Let's go to, yeah, about 1:20. That'll work for now. Okay, so first of all, we need a parts list. We need to know exactly how much pipe of each size. We need to know how many flanges and other components we need to get. So the first thing we're going to do is drive one of the SolidWorks bills of materials. All right, and just like that, I have all this accurate information. You can see I've got item numbers and quantities. Okay, there's those welding neck flanges, the 2 4-inch. Yep, quantity 2. I remember doing that. And then there's the 3-inch, only one of those. Okay, and the number of elbows, everything is counted in the actual SolidWorks assembly, so I don't have to do it manually. That's one of the advantages of modeling it in your 3D assembly, is not only do you find out problems and clearance issues early, but you get accurate completely accurate bill of materials. Okay, notice when it gets into the pipes, again, we get nice descriptions and then the length of each piece of pipe. Okay, what size pipe it is and the exact length of it. Okay, then we can go out and add another column and total all the different sizes, just like we would in Excel. Okay, this is really valuable information. Some other things we can do is some ballooning, so we can easily match it up with the bill of materials. Okay, automatic, which is the way I'd like it. I don't want to spend all day on this. And you can see it puts out these balloons. And the magnetic line allows us to move things around a little bit to clean things up if we want. Spread them out a little bit. Again, get a nice, clean, professional looking drawing with very little effort. That's the key. All right, looking good. And again, number 3 is the elbow. Yep, it sure is. Okay, quantity 3 of those. All right, so again, it's easy to document, very little work. Let's do a little bit more documentation here. In this assembly, we're going to turn on that 3D sketch so that now we can put some manufacturing information on here, like some dimensions. Again, I just kind of freehanded it a little bit, but with some, in the assembly, I could put some very specific dimensions and hit specific numbers I'm trying to hit. There we are. We can dimension to anything, just like we could in any SolidWorks drawing. There we go. So again, very little work to create this complex pipe spool, very little work to document it accurately, and now we're moving on. Again, with smart features too, also doing some of this tedious stuff for us. We've engineered it once, it works, we've got tooling setups for it. I don't want to keep redrawing it every single time I've got a new design. All right, so that looks good. Let's close that and look at a customer who had good luck using this. Here, we'll open another part. Okay. Okay, Consultech is a power plant provider in Canada. And again, just moving from 2D has been huge for them. Again, imagine being on the receiving end of a picture like that on this slide, where this is what the proposal is going to look like, not just some flat 2D drawings, but you get a real, because we're modeling in 3D, we get those accurate mass properties of everything. We get accurate bills of materials. And then we can, not only visually, we can really see what this is going to look like, and this is going to make your bids stand out versus someone who's not using 2D. So they were able to speed things up by 40% and reduce man hours by about the same. But again, because you can see how when SolidWorks automates a lot of these design tasks, you're going to just get things done a lot faster. All right, let's look at how simulation can help. We talked about we need safety for sure, absolute safety and reliability on these expensive projects that we can't afford downtime, we can't afford having things break. We need to know ahead of time where the problem areas are going to be so that we can design parts that can withstand it. So with SolidWorks Premium, you get SolidWorks Simulation, which is a finite element analysis tool that we can apply loads, real-world conditions to our designs and see what the performance is going to be like before we ever have to build one of these. All right. With simulation here, let's just load it in. Again, with Premium, you just get these extra functions and you just turn them on when you need them. All right, so let's go through a simple one here just so you can see it. It does a linear static stress and strain on assemblies. Okay, I'm just working on a single part here. I'm just trying to analyze this part. But again, we can do assemblies, find reaction forces and other things in there too. Just looking at a simple example here. Where let's just look at how we can explore something again without having to spend any time or money building one of these things and then physically breaking it. Okay, you can see by this list here, we can do a really wide range of very complex problems. Okay, so it really just depends on what you need in your environment that you're working. I'm just going to do a simple static one here. There are higher levels of simulation so that you can do whatever complex study is necessary. All right. So on this one, we've got two versions. We've got this one with a web or two walls, and then we've got another one with a single wall, and we're trying to decide which one's going to work better without, again, having to make one of these and then break them. So the first thing we have to do, this is made of cast iron, and we've told SolidWorks that, so it has all the moduli and other kind of important mass properties and other properties of the material so that it knows how it behaves under load. We need to restrain the model before we can put a load on it. And again, for this first pass, we're just going to act as if this face here is welded to the wall. Okay, so we're just going to fix that face there. All right, looks good. And then we need to put a load on it that's going to be hanging off this end. Okay, that's our external load or a force. But you can see we can apply torques and pressures, thermal loads, all kinds of things on here. Okay, I'll apply it to the force, but I don't want it acting in that direction. So we can always take it, and I can use a reference on the model to point the direction that I want the force to act. All right, we'll say 45 pounds. It's going to be our worst case hanging off there. All right, so we've got a material, we've got a restraint, we've got a load acting on the model. And now it's going to mesh the model, which is going to break it up into known elements, and then it's going to run several thousand equations very quickly to find out how this model looks. All right, so we get a real nice colorful plot that tells us right away, our eyes go to the red. That tells us that's where the most stress is. Okay, good to know. All right, it's in the web. That's about what I would have expected. It's nice to have that confirmed. And what are we seeing about, what does that say, about 1600 PSI? Okay, it's good to know. It's well below the yield strength. All right, so now the way we can explore or iterate here, this is again a huge time saver. So right from here, I want to try the same test on a different design and see which one is better. Makes sense, right? All right, so we're going to copy this study. We'll call it static number 2, and it's going to be on this other configuration of the model, and you'll see it change here. Okay, so we could have gone in and changed the geometry. We could have just made it longer, shorter, or thickened something up, or thinned it out, or changed the fillets. Or if we've got two different configurations, which is, again, another way to manage multiple part variations and assembly variations, we can just call up the different configuration of the same part, and we'll run a study on that. Okay, so you can see it's got the single web now instead of the two on the edges. But everything else is about the same. You notice I don't have to redo the fixture or the load or anything. Because the geometry is different, it does need to run the study again, but that's it. I don't need to put in any more effort other than copying that study. All right, so here's what this other one looks like. Okay, stress is in the web where I expect, but notice that we're at about 1200 PSI now, so I already dropped by about 20%. So that's interesting. That's good information to have. Okay, so maybe this is the way to go. You can see how you can quickly try different ideas where it's very cheap to do it on the computer with just you and SolidWorks simulation versus master machinist building a prototype and then a physical testing rig, putting a load on it, trying to break it, finding something out, and then having to make another prototype to see, to try our improvements. Here we can do our improvements in multiple iterations to find which one is going to be the best. All right, so that's just a very basic look at SolidWorks simulation, but it gives you great engineering insight into your designs and how they're going to perform when they get out into the real world. And we need to know that, as I said, up front, so that we don't need to make as many prototypes and we can get to market a lot faster. All right, we're going to load up a model and look at another happy customer who used simulation. This is a local customer to me down here in Southern California. Wiggins Lift makes very large, very specialized forklifts for moving boats around in marinas. As you can imagine, nobody wants their boat to be dropped off of a forklift that just broke. So these things really need to work. They really need to be able to handle the loads they're designed for, and we need to know up front if there's going to be any problems. So they were able to use SolidWorks simulation to get their forklifts. These things are one-offs, and they need to be done really fast. Okay, so this project for the Sea Ray 370 was the world's largest boat handling forklift, and they did it in 2 months from start to finish. And simulation had a big factor in that because they weren't welding up as many prototypes. All right, so let's look at another way, how we optimize for manufacturing. Again, tolerance is everything. We'd like to be as loose as possible because that's the cheaper way to machine things or manufacture things, but it doesn't mean that our designs will always perform if we're too loose. So we want to manage tolerances, make them tight and critical where they need to be for function, and let them be loose elsewhere where it doesn't cost us as much money and it's not as big a factor. So what this is a sheeting machine. It's for cutting material. Again, using a display state to help me kind of focus a little bit more on the blade system here. You can see how it works here though. It's just a camming or an eccentric drive here that just pushes the blade up and down as the material moves through. Okay, simple enough. Okay, but as you can imagine, the distance, let's take a look at that, between this blade, the two blades here, that's critical, right? Too far away and it's not going to cut the material. Too close and we're going to get a crash and the machine's going to eat itself, and that's really bad too. One way it doesn't function, the other way the machine destroys itself. So we need it to be right. Okay, so what we do is we use DIM Expert to tolerance our part. Every part that's involved in this tolerance analysis study needs to have, at least for the features that are being studied, need to have the DIM Expert tolerancing information on here. So we've got a scheme on here that we think we like, but again, we need to run an analysis to make sure that things are going to function. Okay, so back to the assembly. All right, and let's take a look at this study that we've got in here. Okay, first of all, we solve for a dimension. And again, that dimension is the distance between these two blades here. I have a goal. Right now, it's modeled nominally at 0.1 millimeters. But I know that's not going to always be that way once we start manufacturing. So it needs to be between 0 and maybe 0.25 we can live with. Definitely can't be negative, because then that means the blades are crashing into each other, and bigger than 0.25 for the material we're cutting, it means it's just going to put a crease in it. It's not going to cut it. Let's go back a few steps. But what SolidWorks does is it looks at the order that the parts are assembled. So we have the base block, then we have the bottom blade, Okay, then we have the guide pins in there. You can see these vertical guide pins. Okay, those are placed in the lower block next. And then we have the bushings guiding. Then the top block, and then the upper blade then goes on. So it looks at that, the order that things are assembled. Okay, and then at each condition where parts meet, we can tell them which is the critical constraint. Okay, so like this upper blade here, we can see that, you know, let's bring this down. You can see that, you know, the upper face, you know, mates up against that top block, but that's not really going to affect the distance that we're trying to solve for. Whether that's up an inch or down an inch doesn't really matter to that other distance, which is 90 degrees to it. So we tell it that this is the more important constraint here. Those faces as they meet up, because obviously if one of those faces moves, that distance for the cutting moves. So that, and you just tell it that's the important one that I'm trying to solve for. Okay, and then it just looks at all the DIM expert information on all those features and what the tolerances are, and it runs an RSS study, and it gives us a min max. Okay, again, the nominal is 0.1, which that's how we modeled it, and CAD models are perfect. The min is negative 0.91, so that's really bad. That's the blades chewing on each other. Max is 0.321, which is, again, too big. So we're trying to tighten things up a little bit, and so here's where you get what you pay for here. Not only is it telling you what the min max are, but it tells you what the major contributors are. Okay, so at this first one here, what's the, let's see if it, there it is, 52%. So that's the largest contributing factor to the min max. Okay, so we select that, and there's that DIM expert information, and we can just click on that and pull up the tolerance. Okay, so this positioning tolerance at 0.2, yeah, maybe that's a little bit too loose. Let's go 0.04. Okay, so we're going to tighten it up quite a bit. And we have to understand, yep, that will be a little more expensive to machine. But again, we need it to work. So just by making that change, then we recalculate. Okay, so just by changing, doing a what if I tighten up this one tolerance for these guide pins? Okay, now we see, well, at least we're not negative, so the blades won't crash. 0.022, and our max is 0.209, so we can get a little bit bigger on that end. Okay, so here's another one where these bushings fit in. So now I just go, now what's the biggest contributing factor? And it's this these bushings, okay, 64%. So I'll go in there and I'll tighten up that tolerance too. And you can just see where that's how you slowly and just do what if scenarios on your tolerances until you get the range you're looking for, and you can always be looking at the cost for tightening those tolerances too. This is really valuable information to find here rather than trying to do it in a spreadsheet, manually referencing certain nominal dimensions. Here again, it's looking at the model, at the features, it's looking at the DIM expert tolerances that are already on the 3D models. It's crunching the math in the background to give you these RSS and min-max. Okay, so again, that's really valuable insight into your design so that when you do cut the first one, it's going to be accurate. All right, here's another happy customer, RTS Wright Industries. They were creating a new automated robotic system. Then they had been working in 2D, they went to 3D. You can see where the tools in SolidWorks Premium, again, help reduce their errors and the whole design cycle by 20%, design costs, design errors by 50%. And again, compared to 2D, that's very believable because again, in our assemblies, we have collision detection, we have hole alignment tools, we have all these ways to validate our designs in 3D in the computer before we ever cut metal so that when we do, everything is right the first time. Okay, less scrap, That cuts costs. All right. So again, rather than trying to specifically just go, you know, I guess piece by piece, what's in SolidWorks Premium, I will do a quick rundown at the end so everyone has a good summary. But again, we wanted to focus more on the industry you're in and what are these modules inside SolidWorks Premium that can help you the most. So again, these are the specific advantages that you get with SolidWorks Premium, and it's that eDrawings Professional, being able to communicate with people, multiple locations, CAD users, non-CAD users, 3D Content Central and Toolbox, again, for all those vendor parts and standard fasteners. There, again, you just should not be spending any time on stuff that already exists, is already in production, and you're buying off the shelf. So getting those 3D models, getting them to automatically populate fasteners in your assembly just saves nothing but time. The routing functionality, again, you saw with that processing skid. I got an entire pipe spool with all the equipment and dimensions and individual pipe lengths and other fittings, a fully accurate bill of materials in just a few minutes and just a few clicks. Again, those are those kind of process-specific or industry-specific tools that are in Premium that help you get work done a lot faster. As I said, it's possible to do those one by one. I could have mated the flange there, and then I could have drawn a pipe and mated that, and then drawn the valve and then inserted that in there. But again, when changes happen, then I need to change each component individually, not to mention just how much time it takes to do one component at a time versus just driving everything with the 3D sketch. I just can't tell you how much time that saves you. There's lots of ways to simulate or validate your designs using simulation. We can put a load on things. We can also do kinematics analysis if you're trying to find required loads to actuate a mechanism. And again, there's just no substitute for finding that out virtually, where it doesn't cost nearly as much money or take nearly as much time. The PDM data management tools, again, for those who have compliance obligations or in heavily regulated industries like energy. We need to have a paper trail. We need to always know the correct versions of parts that are being manufactured, that are being integrated into certain designs. PDM also allows us to take one project and create a whole new project based on an existing one, and then make only the changes necessary where that design is different, rather than starting from the ground up every time too. So again, that's that design reuse and eliminating the tedious tasks. And then just what's in SolidWorks in general, even the standard version, you get all these very specific tools for weldments, which are very popular in this industry. Sheet metal parts everywhere. You draw three-dimensional sheet metal part. You have a developable flat pattern, so that for manufacturing that takes into account all the deformation of the bent edges. So again, that's extremely valuable. And now again, just so you're aware of what is in the entire premium package before we close out here. Again, SolidWorks Standard is a full-blown 3D CAD parametric program, parts, assemblies, drawings, specific geometry types like sheet metal, weldments, very complex organic surfacing, and being able to animate your assemblies, design validation tools, as I mentioned, clearance detection, hole alignment, interference detection, so many ways to get good information from your 3D model before you ever have to create one of these. Okay, then SolidWorks Professional adds a lot of productivity enhancements to everything that's already in SolidWorks Standard. So that gives you the file management tool. So now, rather than doing it manually, you have a secure vault that is keeping track of all your revisions every time you check something in or out of the vault and make changes. It's a lot better to have the software taking care of that for you rather than you having to use manual file management techniques. You can make mistakes, not to mention it just is way more tedious. That's where the components and fastener library comes in, toolbox, over 1 million parts. You get advanced photorealistic rendering, so we can calculate how light bounces off of your object with different materials and put scenery in the background and get photographic quality pictures of this design, again, before anyone ever starts any construction. eDrawings Professional is what allows us to use eDrawings and then add those extra capabilities like pulling measurements off and doing markup, putting in your input and sending the eDrawing back. Great way to communicate. Cost estimation, printed circuit board integration, again from PCB CAD. Those files are tricky to get into parametric mechanical CAD. SolidWorks, which is part of Professional, makes that very easy, and it's also two-way. Reverse engineering, so we can scan objects and bring them in and get 3D models for that, for things like ergonomics. Tolerance analysis, what you just saw. Okay, so PDMWorks standard, as we said, it's for smaller groups, but I do revision control and workflows, very basic workflows. There's a higher level depending on how big your group is, and other things like multiple locations and things like that. Just know you will get the tool that will help you do that in this package. Okay, a little bit more about Toolbox. Again, not just ANSI standard too, all kinds of international standards and sizing increments based on those standards, over 1 million different parts. Again, if you use a lot of hardware, which this industry does, there's just no time to be drawing these things yourself. Okay. The visualization tools for photorealistic rendering, again, if you need to, for a bid or some kind of price estimate, you want to, if you include, it's because you've already drawn it in 3D, if you want to include a realistic picture of what the installation is going to look like, again, that just makes you stand out of the pack versus your competitors. That's what the markup would look like in eDrawings Professional. Just draw a 3D note and point to an area that you're concerned about so that there's no confusion. Costing is, and rather than again using tribal knowledge and spreadsheets, it looks directly at the 3D model. It collects things like sheet metal bends and perimeters and things like that, and runs it against your own information on maybe a laser cutter or something, and gives you a cost estimate built right into SolidWorks, which is really nice. The circuit works, as I mentioned. Design Checker allows you to set up your company standards for drawings. And then every new drawing, you can just have a batch process run against that to check, so you don't have to do it manually, which takes a lot of time and which is almost impossible to get correct every single time. Yeah, there's also a command, if it finds errors, it will also correct them according to the standards. Okay, let's talk about tedious work being automated. Especially if you have a stack of drawings, Design Checker can save you a ton of time in it. You can also batch process it to do it while you're not even at work. You can batch process other operations too. Again, to happen at off times. But again, you can see the value here, like something like export files. Let's say you had a new project and you want to export all the machinable parts to a step files, so for the machine shop. Okay, without Task Scheduler, which is included in Professional, you'd have to open every part yourself, one by one, save as, step, close the file, open another one, save as, step. If there's 50 files, that's going to be taking you a long time. Whereas with Task Scheduler, I can just point to that folder and say at 7 o'clock tonight, every part file in that folder I want saved as a step file and saved to this other folder. Go. So I set up that command, and then at 7 o'clock, that happens. It opens, SolidWorks fires up automatically, opens every part, saves a step, done. So it's just, you can just see where that's not really a good use of my time. So that's a big time saver there. Okay, Tall Analyst we talked about. reverse engineering for scanning objects and bringing that in. And then Premium takes everything in Professional, includes that, and then adds more to it. Okay, and that's where it gives you the linear static stress of assemblies and parts, as you saw. Okay, virtual prototyping, if you will, which again is much faster and cheaper. SolidWorks Motion for looking at moving parts and mechanisms and looking at loads required to actuate certain systems so that help you source motors and actuators accurately. You can get different plots looking at acceleration and displacement, reaction forces, routing, as I said, piping and tubes, accurate bills of materials, as well as electrical cabling, wire harnesses, other types of sections, rectangular, circular ducting, cable trays, all using that same method of 3D linear sketches going around and then it putting the individual parts on there for you. Okay. Premium also has advanced surface flattening, which takes complex surfaces or compound even, with multiple bends in there or curvature, and being able to flatten that. So for things like graphics and textiles, it's nice to know maybe where some compression or some stretch is going to be as this flat object is then wrapped around this complex shape. And it allows us to know maybe where we need some relief cuts or something like that. And we can get that flat pattern of that surface in a DXF or DWG file so we know what size to cut to fit. So again, it's very specific, but it's very powerful information. And the last one is SolidWorks sustainability. So for those of you, again, especially in industry, if we're looking at environmental impact and we're either using it as a differentiator, competitive differentiator, or if we are required by government regulations, it looks at the material that goes into your design, how it's manufactured, different manufacturing methods, the transportation, how your product gets to where its final location, and then what happens to it at the end of its life. It looks at those 4 aspects and then gives you an idea of the environmental impact so that when you make changes to materials or certain things, you'll get some feedback knowing if you're improving the environmental impact or making it worse. And it prints out an automatic report so that you can approve your life cycle analysis. All right, and that puts us at 1 hour. Again, thank you very much for attending today. Again, just looking at SolidWorks Premium and how it can help you in your specific industry get your job done better and faster. Thanks again for attending today.